The purpose of this presentation is to provide advocacy for the pre-owned Continental O200 engine. During the process of selecting a suitable power plant for your aircraft project, it becomes apparent that the popular engine choices all have their own advocates to deliver the message that their engines are best. The list of popular engines include Rotax, Jabiru, UL Power, Viking, Corvair, and more. Each of those organizations have a commercial interest in shining the brightest light on their engines. Those are all great engines, and they deserve the interest and sales that they get. The pre-owned O200 is often overlooked as a viable choice for a home-built project. The reason for this may be due in part that there is no central resource of knowledge that's available for procuring and installing this engine in an experimental plane. Our goal here is to work towards building a central knowledge resource for this purpose. This DVD video presentation is a work in progress. We will try to create new versions as new information becomes available.
If you want the most pain-free, simple installation, choose a complete firewall forward package from Zenair.com. It will be the most expensive path, but will be the most complete package. Details are available on their website, with a description of the components included. These kits can also be adapted to other than Zenith aircraft by eliminating the parts not appropriate for your model aircraft. The other path to take is to source as many of the parts you need from the open marketplace, both new and used. eBay and Barnstormers have a wide variety of aircraft parts that can be obtained at heavily discounted prices. You have to be savvy in your analysis and research to make this work. Also, vendors like Aircraft Spruce have many of the same parts brand new. By watching this video, you can get a good idea of what parts are needed and how they fit into the project. The installation shown in this video used a combination of Zenair products and manually sourced components from local suppliers, including eBay. This method was chosen to demonstrate the range of cost and challenges that will result when using parts that don't always work well together. What is advocacy without at least a short talk about why the O200 is a fantastic choice for your home build? It was designed and built to be an airplane engine, period. The O200 model has almost 80 years of track record behind it. Why does that really matter? Reliability and safety. Affordability. You can choose to scrounge every component and have them all inspected for reliability and build the engine yourself. If your desire is to have a reliable engine for the fraction of a new price, it is a common practice with the O200. Parts availability. No other engine manufacturer has the widest selection of replacement parts, even from third parties. This fosters competition and keeps the engine affordable for maintenance. Support. If the airport you land at has a maintenance shop, they will be familiar with your engine and can get the parts as needed. That is a lot of mechanics that know your engine worldwide. Documentation. The complete overhaul and maintenance manual is available online for free. You have the opportunity to understand and repair your own engine. You won't find a simpler engine to work on. Fuel runs on automotive or aviation gas, or a mixture of the two. Weight. A great myth about how the O200 is too heavy to compete with the modern engines in our list. The big problem with engine weight is that it is often not reflecting the total weight of all components needed for an engine installation, like radiators, coolers, mounts, etc. A forum on the zenith.aero website displayed average aircraft weights grouped by engine models. These aircraft weights don't allow us to cheat when comparing engines. The results? For the CH-750 aircraft, the average aircraft weight with an O200 was just 7 pounds higher than the same aircraft model with the Jabiru 3300. The O200 aircraft average was less than the Corvair and Viking models and higher in weight than the Rotax and UL Power models. While these are not scientific results, these numbers came from the builders submitting their numbers voluntarily. Everyone builds an aircraft differently with different options, but the trend clearly shows the O200 to not have the weight liability often expressed in the internet media.
And here is the O200 engine mount from Zenith. I believe this one is made at Zenair in Canada. And it has a piece of plywood bolted in place of where the engine will mount. Now we're just trial fitting the engine mount, and one thing we notice is that at each of the areas the rectangular pad needs to be trimmed. I've made a line in order for it to fit. After holding the engine mount up to the firewall, it was determined that some trimming was necessary, so this corner area is going to be removed on both sides. We're going to use a cutoff wheel, air powered. Be sure to wear eye protection and just cut that right off and then trial fit again. And then we'll use our grinder to clean up that edge. One of the first steps in preparing to drill for the engine mount is to locate the hole and drill through just with the pilot hole, which will take us into the steel weldment on the other side, here and over here. And the same down here, if this hasn't been drilled yet, this needs to be drilled through, and that will pass into the steel weldment, the engine weldment mount on the other side. Now we can put the engine mount back in place, and we'll eventually back drill from the other side of the firewall forward into the engine mount so that we get a nice accurate location for the hole, using just the pilot size at this time. With the engine mount clamped in place on the left and the right, we're then going to trace with the pen around the top pad so that we can mark exactly where the bolting location will be when we remove the engine mount. With the mount removed, we can go behind the panel and we notice and measure the cabin frame tube pad and then transfer its outline on the front, and that's what I did with my green marker. And then basically I located two marks where the two pads of the engine mount and the cabin frame tube pad overlap, and picked a good location with plenty of edge distance for both of them. With these marks, I will then drill through the front and into the pad. I'll clamp these together to make sure they don't move in relation to each other, and I can drill a pilot hole at both of my locations, and then we'll put the mount back in and transfer that hole to the mount. Now with the engine mount back in place and our holes drilled through the firewall, we can drill from behind the firewall and into the engine mount. We can either drill all the way through, or if necessary, we can mark it and take the mount off and complete the drilling that way. So we have drilled the top and the sides, and I reinstalled the board. The board has the effect of spacing each of the mounting locations exactly as required by the engine. And what we will find is that if we were to attach all of our points to the firewall, it would spread this just a little bit, and then the board wouldn't fit again. Drilling out to full size, to final size. Now it's time to prime and paint our engine mount to protect the steel from rusting. And it will also be a good time, with the mount removed, to lay out and investigate what holes and other breaches we want to make into the firewall, because access will be easier at that time. And once we remount the engine mount, it might be a little harder to get in there. Here is the engine mount after I have painted it. I simply use some rattle can Rust-Oleum enamel. So we can go back now and fit this up to the firewall. And now we have the mount bolted in place. We use the metal lock nuts to keep our inspectors happy. Sometimes they complain when they see the plastic ones used, although I don't think there's anything wrong with the plastic ones on the firewall. Here the firewall mount bolt has been sized up to the 3/8 as specified.
This would be a good time to reinstall the board on the front of the mount. What we want to do is to make sure that from a vertical standpoint, the board is perpendicular to our cabin frame. You can measure this against the horizontal cabin frame tube. The idea here is that with the engine hung on the mount, we want the propeller flange to point directly forward, not pointing down or pointing up. If the board does need some alignment, this is the time where we can shim under the engine mount tabs where it attaches to the firewall to ensure that our engine mount is truly perpendicular to the airframe.
Here is from behind the firewall. Here is the Lord mount assembly kit that I received from Fresno Air Parts. Now, it does not include the bolts, which I purchased separately. We can take a look at how these components go together to form our mount. Basically, these rubbers are all the same. One side is a little different from the other. One has the groove. So we take one of these cupped washers, and it fits very nicely on the back. And then one of these rings fits very nicely onto the groove. So we get a little sandwich like that. And then we just repeat that one more time. So we end up with two of these. And the engine mount itself on the engine goes right in between here. Right in between. And what holds this together is one of these cylinders, and we push one of the hoses over the cylinders. I put a little soapy water on that to make it easier to push, and roughly center it. And we can stick that inside of there, and this inside of here. Now, the engine itself, the mount on the engine is in the middle, and then we use a bolt to go through all of it. Note we have the engine lifted on a hoist. The Continental has a nice attach ring, and notice it's almost, I don't want to say perfectly balanced. Notice it's a little forward, and that's because I currently don't have an alternator on the back, and the original alternator, I believe, was 12 pounds, so that would have made quite a bit of difference. And the tire was a wonderful way to be able to flip it from being originally upside down while transporting to its location. And with a couple of people, it was easy to rotate it around once the hook was attached. This type of hoist, which you need to beg, borrow, or steal, has casters, so we will be able just to swing this around towards the aircraft. Loosen that a little bit and then pull down on the arm. Here is the engine after it has just been hung. I tightened the mounting nuts until they bottomed out on the internal metal sleeve inside of the rubber mount, and then tighten a little more and set the cotter pin. The lower two mounts, I had to have the bolt head towards us opposite of this one because there wasn't enough clearance. That's a SkyTech starter in the center, and the two magnetos left and right. And below that will be the alternator as soon as I acquire one. And here's a look underneath.
The area with the blue tape is where our exhausts attach, and the metal bosses right below the spark plugs are for screwing in a cylinder head temperature probe.
For the battery bracket mount, I took a piece of extruded aluminum. 3/4 by 3/4 is fine. Mine was 3/4 by an inch, a little bit longer. Doesn't matter. And the length was approximately 170 millimeters. And I created five equally spaced holes, and then placed this up onto the firewall and used these holes to drill. And let's take a look at where I located this on the firewall. I'm going to install the battery against the firewall onto the little shelf we installed previously. I'm going to use one of these Odyssey batteries. They are heavy. I think this one's about 14 pounds. They are very nice. For a little more money you can go with the less heavy ones, but I've decided to go with this, and it will fit very nicely on the shelf. The connections are on the top, and I'll simply put it in place. I have also created a bracket. I did this on my simple brake, and basically just measured the battery, the top and the side, and I will use AN3 hardware at the top and bottom to bolt this tightly to the firewall at the bottom and at the top.
TV in the US and 90 million around the world. King won the match, making a statement not only for women's tennis, but female athletes throughout the country.
The copper-colored stud above is the ground connection, as on the other side. And this is our grounding bus. Not completely installed yet, but in its proper location. I'm going to start cabling or wiring some of my components. Here is my contactor and my old style voltage regulator for the alternator. Of course, our battery and the grounding stud. And I have installed a small bus bar. This is simply a multi-point connection terminal with 4 studs and nuts, and this will allow me to connect my 12 volts to the rest of the system. Here are my battery cables and starter cables. You can have these made up for you. Tell the local shop what length and what size ring terminal, depending where you're connecting to. Or you can do these yourself. This is basically welding cable, which is readily available at either a welding shop or electrical supply. And then these ring terminals are easy to obtain. They just need to be sized for the size of wire. I'm using number 4 here, and you need a crimping tool to put those on. So whether you do it yourself or have them made, they are important and should be sized properly. We're going to, like I say, use number 4. That'll be more than enough amperage capacity for starting.
for the starter from the battery. Red is just used for positive and black for negative, though welding cable usually comes in black, and you can use red tape or other indicator if you so desire. When it comes time to pass through the firewall with your wires, one option is to use a bulkhead pass-through. This is made out of nylon. I got it from Aircraft Spruce. It comes apart, which means you can place it on even after your wires are in place. And you simply drill a hole of the appropriate size, and it's got some little tabs so that it fits together nicely, and you can put it in place any way you want. If the wires don't take up the entire area, it's easy to wrap this with a silicone hole or with fire seal to close up the space you're not using, and then we'll seal it up with some silicone seal, high temperature silicone seal, to prevent gases from being able to pass through into the cockpit area. But just one idea. I think these were about $15. Here is the location for the alternator, which we are going to install. Uses those 3 mounting studs and nuts. On our installation, we're going to use a stock alternator. Originally was installed on the O200 from a Cessna 150 typically. This one has been checked out. It is a little bit on the heavy side. It's about 12 pounds roughly. You can save probably almost half that weight with one of the more modern but obviously more expensive units. And saving weight is always a good thing. But for now, we're going with the stock unit. On the back, you will notice from an electrical standpoint, we have the large post, which is our main alternator output. And then this is the field connection, which will come from our voltage regulator, and then ground. We're not going to use a secondary ground, and we're not going to use the terminal marked STA. And on the front of the firewall, we have our bulkhead fitting as we route wires through it, voltage regulator, and main switch contactor. We have also wired up the alternator, and we are still wiring at this stage. For our cabin heat, we have a relatively simple system. We're going to mount a 2-inch flange on the outside of the firewall. This is where we will attach our hose, and then drill a approximately 2-inch hole. And then on the inside, we have this valve from Zenith, which is basically a 2-inch flange with a butterfly valve on it. And this will go on the inside, and we can attach our push-pull cable to regulate the opening of the air. So these will go back to back with the firewall in between. This will be on the outside, this will be on the inside, and will regulate the flow. The location of our hole is located just above and beyond the battery. We can use a hole saw and then mount both pieces on each side of the firewall through some holes and rivet or bolt together.
Here is the outside of the firewall, and if we take a look inside, and that comes right about where your feet are located behind the rudder pedals on the pilot side. To hold the cabin heat cable, I created a small aluminum bracket, just bent this up and put a hole in it, and that's going to hold our cable adjuster. This is just a garden variety type of cable adjuster, and it will insert into the hole with the nut on both sides and allow us to adjust the cable length. And I'll go install this on the inside of the firewall. I've mounted our bracket, and note that when the cable is installed, it will aim towards the lever on our butterfly heater valve. I have the cabin heat cable installed. I have marked it where I want to cut it. So with this cable, all I have to do is pull the inner core out, all the way out, until I get it past the point where I want to cut it. Then I can go ahead and cut this and then reinsert the cable in. Here's the location of the holes in the firewall for our control cables. Towards the center on the passenger side, I have made two holes. I'm going to have a single throttle, and to its left looking here is the mixture hole. The carb heat is located on the pilot side, and you can see I have routed the cable through the hole. Here is one of the magnetos that I have removed from my engine. This part here is inside the engine case. So this is the part we will see from the outside. Now the reason I have removed it is so it's a little easier to see. We need to connect a cable to each of our magnetos. A single lead, a single shielded lead, for the purpose of disabling or grounding the magneto, making it stop, produce its spark. Now there's a number of different variations of magnetos. This one I have here is a Bendix model. There's another group of magnetos named Slick, and there's some other ones, but this is a typical one. We need to connect our wire to this port here. Now if you have the original wiring from the engine, you're going to be all set, but many of us aren't going to have the original wiring. So it's our goal as builders and installers of the engine to come up with a secure way to attach our cable to this port, and there's a single contact way inside there. One method that I found was useful was to purchase a P-lead adapter. I bought this from Aircraft Spruce. It wasn't too expensive, but this is used for mechanics, and it simply screws into the port and makes a nice contact to allow mechanics to attach an alligator clip, a temporary lead to here so they can do their timing and testing. Well, one way to take advantage of this is to purchase a set of these. You have two magnetos, so you will need one for each. And our goal is to find a way to make a permanent connection to this brass post. And one way to do that is to tap the end of the post. Notice I have a nut on here, and that's because I threaded the post, and that's doable by simply purchasing an appropriate die and then cutting the threads onto the post. This was a 3/16 32, so the size is 3/16 and 32 threads per inch, and that gave us a typical thread for a nut like this, 632 nut. So if you have a machinist friend or want to attempt this yourself, simply convert an untapped post to one that has a tap on it by cutting the threads. Now we have a very easy way to attach a ring terminal to this, and I'd put another nut on top of it, and then we need to ground the shield, and I'll ground mine right there. Here's an example of the cable I made up. This is a number 16, I believe, shielded wire. So there's a shield on the outside and a number 16 stranded on the inside. And I simply attached terminal to the inside and a terminal to the braid, the ground, and that will allow me to attach and secure the cable to the P-lead and then the ground to a grounding nut over here. And then the other end of this cable will go to our switch inside the cockpit for grounding or turning off and on this cable. Basically, when this conductor is grounded, the magneto stops producing a spark. When we unground it, it is allowed to create a spark. So that's just one method of coming up with a way to attach your P-lead to your magneto. There are other magnetos that, and I believe it's the slick variety, that has a stud automatically, or that has a stud built into the case, in which case you don't need to worry about doing everything I just talked about here. I have removed one of my magnetos to show you where I'm going to attach the tachometer pickup, the electronic tachometer pickup. Now, I have a Bendix mag here. The other type, the slick, is a little bit different, but basically the same function. On the Bendix, we have our plug here for sighting, for timing purposes. Then on the bottom, there are two ports, and I've removed one of the plugs from the port. As I understand it, these are for vents. But the reason I removed it is because this is where I'm going to insert the sensor that's going to pick up electronically the tachometer pulses for RPM reading on our electronic readout. This is a electronic pickup, and it has a thread, and they talk about maybe using a little Loctite on this, but this will thread into the port. And one reason I may not use the thread locker material is that there is no swivel on the wire. The only way this can rotate around is if you rotate the entire cable assembly, so we want to be careful doing that because we don't want to twist the wire and break it off. So I'm going to twist it around until I get it on there. I'm going to be careful starting it. Now, there is no opening on here. This is basically an electronic device that is going to pick up the rotation of the magnets as they spin around in here and get a count for our readout. So I'm going to simply thread this in place, and I will thread it around and around until it bottoms out. There is no swivel on the wire, so we want to be careful and make sure we rotate the wire around with it until it's tight. Now, this will never come out once we have the wire in place, because the wire would have to be able to twist around on itself, and that's not going to happen. And now we can go mount this. Now, we're only going to measure one of the magnetos for the RPM for the engine. We don't need a second one, but we will carefully install these. Now, if you're not familiar with installing magnetos, you want to have your mechanic take care of that, but basically we're going to remove this plug. This is our sight gauge. And if we look very carefully inside, we're going to look on one of the gears, and there's a painted mark. I'll find it first. So I'm simply rotating the gear, and I found the red mark. I don't know that you can see it in there, but there's a red mark and a tiny pointer in there. And once we get that red mark against the pointer, simply by rotating this, we'll carefully leave it, and now we can insert it into the engine, assuming we have set the engine properly. In other words, piston number 1 on the compression stroke at top dead center for my engine. Now you want to review this with someone who knows for sure, but that's the procedure on my engine. Once the crank has been turned for piston number 1 on the compression stroke at top dead center, and we have turned our magnetos till we get the red mark lined up with the pointer, now we can carefully insert this into the engine, and the rough timing will be done. The fine timing is done with these slots on either side. Turn it around this way, there we go. And notice the slots in here, we can rotate this slightly. But we must get the rough timing set properly by doing what we just talked about with the engine in the proper, crankshaft in the proper position, and our mark in the proper position. Here's a look at the Bendix mag and the little mark inside the window, showing that we have the gears aligned properly. And here is a look at the P-lead connection on one of the magnetos. Notice the center ring connection on the stud with a nut on the top and the bottom, and then the ground connection made on one of the screws on the corner of the magneto case nearby. Here is our Westac temperature probe for the oil. I have severed the leads and put on some spade connectors to make it easier to install and remove this, because we need to twist it, and with the long cable that came supplied with it, that would have caused a bit of a mess. Let's look at where I'm going to install this for our oil temperature. I have the magnetos removed at this time, so it makes it a lot easier to see. I believe the oil screen originally with the engine is installed here, and there is a port, a threaded port, and that is where we will thread this into place. Has a copper washer, and we'll use a wrench to tighten this all the way in.
and that's where we will get the temperature for our oil. We're going to get the pressure from another location near our oil filter. And then of course the magneto is installed right here. You don't have to remove the magneto to install this, it's just a lot easier to see. Over here is the tachometer takeoff. If you had a mechanical takeoff for the tachometer, it would thread in here. We're going to use an electronic sensor attached to one of the magnetos. Before I put the magnetos in, I have that one last issue of capping up the output for the old speedometer tachometer cable right above the alternator there. That's a fine thread, 7/8 I believe, and we can leave it alone. I would like to cap it up just in case any oil tries to find its way out, though I believe there's a seal in there and it shouldn't be a problem. We created a small cap here, which was basically made from a nut, 7/8 inch nut, fine thread, and then welded a cap on the end. And we'll put that over the tachometer port and the cap in place. This is a VDO oil pressure sender unit, which we're going to use to report back the oil pressure to our instrumentation. It has one electrical connection and then ground. And this port here needs to screw into an oil passage to pick up the pressure. Now on our filter adapter, we'll attach this to the engine, oil filter canister on here, and then on the bottom is a plug. If we remove that plug, we have the common location that people mount the pressure sender. You can get a fitting. This is, I believe, 1/4 inch pipe thread, and this is 1/8 pipe thread. So we can get an elbow or an adapter and screw this together. Now, the problem with that is there have been some reports of these units failing because of the vibration. This is right on the engine when it runs, and this has mechanical components inside for the pressure reading. So what we're going to do is remote mount this. In other words, run a hose from here and mount this off the engine somewhere where it won't be subject to the repeated vibration. So it's up to you. Quite a few people do mount the sender directly to the device, and we're going to choose to remote mount it to help protect it from failure. So we obtained a fitting. Now this has a flare on one side of it. That's for a standard 37-degree flare connection from a hose, and then a 1/4 inch pipe thread on the other side. And we'll put a little bit of sealant on here and screw it into the filter adapter. We'll see that this 90 degrees is necessary when we mount this to the engine so that we can position it in a way to have access. Once this is on, we're going to attach a standard hydraulic hose. Here's an example of a hose. Mine is 18 inches long. These come standard in 6 inches, a foot, any length you want, pre-made with the standard hydraulic fittings, flared fittings at each end. And we will then attach that. And this will allow us then to attach the other end to our pressure sender. Now our pressure sender has an 1/8 inch connection, male connection on the end. So again, another standard fitting, 1/8 inch pipe thread to standard hydraulic flared fitting. So we'll screw that on, a little bit of sealant, and then the other end of our hose will attach on. Of course, we use no sealant material on a flared connection. But what this now allows us to do is to mount our sender anywhere we want off of the engine to protect it from the vibration. Now we can go install this on the aircraft. We have the fitting in place, so we're going to install the adapter. And 3 nuts, washers and nuts, hold this in place. We've installed the filter unit onto the engine, and now we will attach our hydraulic line to the flare fitting. And here is our VDO pressure sender unit. It is attached with simply 2 8L clamps, one around our engine support and another one where I have removed the insulation because we need a ground on the body of the unit. So I simply removed the rubber insulation off of the 8L clamp, and we can install it wherever it's convenient and attach the other end of our hydraulic line. Our last step after tightening everything up is to make sure we ground the body, and I'll simply run a cable from the 8L clamp to a suitable ground on the airframe, and then this is our connection that goes to our display unit for our oil pressure on the panel. At this time, we're not going to permanently tighten our filter unit because we're also going to use this entry into the engine for priming the engine when we first started. So I've left our mounting nuts loose so we can easily remove this. In order to monitor our cylinder head temperatures, we have a choice of sensors that we can use. Now here is the probe model, and if your heads have a threaded boss in them, we can thread these in, each of the heads, and then we have a 2-wire thermocouple type hookup that we can run to our engine management system. If your heads don't have the screw-in location for one of these, you can use the very popular spark plug ring type sensor, which goes underneath the spark plug as you screw it in, and they both will connect up in a similar fashion with 2 wires. Now we need to use the specially made extension cable to continue these on to the firewall, and I will be hooking those up. You also have the choice of monitoring all 4 cylinder heads or any number less than that. That's up to you. Depends on what type of engine management system you have as far as its capability and your desire to monitor all 4 cylinders or just maybe 2 out of the 4. Here's a look where the sensor can be screwed in on these heads. And that's the port right there. And that gets screwed in right there. And there's a location at each head for one of these. Otherwise, the ring type simply goes underneath the spark plug. If you want to monitor exhaust gas temperature, then you need to install the probes, such as this one here. These are clamped on with worm drive clamps. That spring is the sensor which pokes into the middle of the exhaust pipe, and the distance from the flange of where the exhaust pipe leaves the exhaust manifold must be held consistent for every one of your EGT probes, so that the temperature is consistent if you're trying to compare them from one cylinder to another. Now I have one EGT sensor on each exhaust pipe, so I am monitoring all 4 pipes, all 4 cylinders. Basically, you just drill a hole into your exhaust pipe at the proper distance and then clamp these sensors into place. The hose clamp, which is a stainless steel hose clamp, affixes the sensor to the pipe, and then a pair of leads come out of the sensor and go to your monitoring equipment. Here are the probes on the other 2 cylinders. On my installation, I have an MGL electronic monitoring system, and all of the wires run into this box here on the firewall. 4 of them are for the EGTs and 4 of them are for the cylinder head temperature, the CHTs. Our throttle cable exits the firewall up here, just to the right of center, and we'll have to patch up that hole with some fireproof caulk later. And then we're going to feed it between our engine mount tubes and then in between this area here of our oil filler neck, because our ultimate destination, of course, is the carburetor lever over here. It's going to go something like that. Now obviously we can adjust this by pulling it through the firewall as necessary. Here are some of the details of how we hooked up our throttle. Now I'm setting up for single throttle, not dual. This is our standard throttle cable. Note that the end is threaded and allows us to use a rod end of appropriate size, so we can thread it on and adjust it for fine adjustment. And our challenge is to be able to affix the throttle cable in such a way that it is safe and secure and does not move in relation to the part that we want to move, because this of course can affect our throttle setting during flight, so this needs to be very secure. Now the throttle cable comes with a groove, a notch in here, and we have a special bracket with a swivel on it. Turn it this way. And the idea here is that we can put that groove of the cable between these 2 notches and lock it in place and wire tie it so that it does not escape. This is made out of nice heavy steel with a bunch of mounting holes. It comes in the shape of an L. So we need a way to mount this securely to the airframe at some location so that it's nice and solid, and then our cable can be placed in the groove and locked in place, and we can wire tie this so it doesn't come undone. And that way also we can replace the
throttle cable if necessary. So the challenge is to mount this in just the right location so that it serves the carburetor. There really isn't any adjustment here. Once the throttle cable is in the notch and locked in place, it's set. So we need to mount this properly the first time so that it does reach the carburetor properly. Let's take a look at how we did it here. And we certainly don't have the only way that it can be mounted. This is simply the way we've set it up for our installation. Now we can pull this cable forward and back because we haven't mounted it yet, and our goal is to make sure our throttle knob on the panel is pushed in all the way for full power so that this part extends all of the way, and then to match it up with our carburetor throttle lever, which has to be all the way forward. So we can position this so that they match full throttle on the cable and full throttle on the carburetor. And that becomes the position we want to mount the cable at exactly that point. We have a little bit of adjustment here, but we want to get it as close as possible when we mount it so that we have the full adjustment available to us. So once we have that location, that's where we want to mount our bracket to capture that groove and hold it exactly in this position. The cable is in its position that we want it, so we need a way to mount this bracket. And here's the groove right here, and we need to affix it to the airframe. Now it's nice that we have this stud sticking down. I removed the nut that was on there, and rather than directly trying to find a way to mount this on here, I made up a bracket. This is made out of 1.25 inches by 1 inch, and I just trimmed it down. Nothing fancy about it. I just used a piece of extrusion and made a hole, and the hole allows me to mount it like this. And what that allowed me to do is to mount my bracket on here using the holes. So I will bolt my capture bracket to my homemade bracket and place it up there. Now, obviously I have already created this, but it's not difficult to do. My first step was to mount this in place. Then my next step was to connect this to the groove. I'll do that right now. Open it up, put it through the groove and close it, and then hold it in just the right position so that it works out for the carburetor the way I want. And with this in place, mark through 2 of the holes and drill. So if you just take your time, you can get this exactly the way you want it. And this gives us the full flexibility to rotate as necessary in this direction and in this direction to get it at the best angle so that our operation is nice and smooth. There is some flex or pivot built into this cable, so it is allowed to go up and down a little bit, but obviously we're shooting for the straightest shot from the mounting location all the way to the pivot point. Now I will assemble these together and then install them so we can see what they look like fully installed. Here's a close-up of the bracket. That's the large mounting hole. We'll talk about that hole in a moment. These nuts are temporary. We'll eventually replace them with the proper lock nuts. And we'll go ahead now and mount this. And the cable will fit in the notch. Now here's a close-up of the bracket. Even if we tighten the nut on the bracket, notice that there's the possibility that it can rotate. And that would not be good. If it ever came loose, our alignment would mess up, and that would ultimately affect our throttle position, possibly while in flight. So anytime we have the potential for a movement from pivoting, we want to make one more attachment. And that's what I have with that second hole in my bracket. Next, we're going to look at installing the mixture cable. Now, our goal is to actuate the mixture lever on the carburetor, which is here. It moves perpendicular to the center line of the engine. And the cable we're going to use is pretty much just a wire cable. After cutting the cable to the proper length, we're going to use a fitting like this, which has a threaded end on one side, 1032, and then in here we can insert the cable directly, and then by tightening this sleeve with a wrench, it will bite down onto the steel cable and will not let it pull off. Then with our threaded end, with a nut, first put a jam nut on, and then our rod end, and then we have some adjustment in here for the length. And then we can use a bolt to attach to the mixture lever. This part is made out of stainless steel and is very durable and offers a very nice solution for tapping onto the end of a steel wire like that. And here is our new bracket for the throttle. 1 inch by 1 inch will do just fine. And this is about 100 millimeters long, and then I just cut out this area. So this started as a standard 1 by 1 inch extruded angle, aluminum angle, and I just knocked off a certain part, and the 2 holes here will be based on setting up the bracket so that it fits just right, and then marking the holes and drilling them as necessary. So the holes will come only after aligning the cable. And here's the bracket that holds the mixture cable. This is about 3/4 inch L angle. The overall distance is 150 millimeters, and I cut away this part of the angle. These 2 holes will hold the little clamps for the cable. This attaches to the manifold stud on the engine, and this hole will connect up with our carburetor cable bracket with a 1 inch spacer. I just made this on the bandsaw. Here is our mixture cable with the bracket and 2 clamps. These are the 1/4 inch clamps, and this allows us to adjust the cable back and forth to get the length. And we have it tied together with a 1 inch spacer, and that prevents this from moving any direction, and the same with our throttle bracket. That can't move in the other direction, can't twist, as it's attached to the large stud here.
and then through this bracket over there. And we need to wire tie the swivel that holds the throttle cable in the notch. And every engine may be a little different carburetors and different linkages. But this is just one example of using brackets that we make out of aluminum angle to give us nice, secure mounting locations for our cables. As we know, losing a throttle or even the mixture can kill the engine at the wrong time and make flight very dangerous. So we do want to give some attention to a good system of mounting our cables.